So in task 1 you learned about exponential functions, how to recognize them, a times b to the x power. And in this task we're going to look at a different form that can be used in general, this formula here. And when it's written this way, instead of b to the x power, notice we have 1 plus r to the t power. And so 1 plus r is the growth factor. And r, the reason why we separate it into 1 plus r is that r gives us the growth rate. So remember, with exponential growth, something is growing by a certain percent each time period. So it could be 10%, 12%, whatever. So that's what r represents. And it's got to be written as a decimal number. That'll be really important. Capital A is what it's equal to, so that is our ending value, what we end up with after whatever time length. And then capital P is the principal or the initial value, so what we start with. And then instead of x, since we're talking about time, we use the variable t. Okay, so example. Say a biologist is studying the growth of a bacteria E. coli, these little red guys over here, in a lab. She starts with 100 bacteria. They grow at a rate of 12% each hour. How many bacteria will there be when she checks on them 24 hours later? So I always like to start by copying down the formula, and then we're going to figure out the different variables, plug them in, and evaluate. So what we're looking for is how many bacteria there will be. So that's our A, so that's what we're looking for. And so then that equals P, our initial value. So she starts with 100, so that's our P value, 100 bacteria. We got 1 plus, and so then R, we need our growth rate. So it says the growth rate is 12% each hour. Now instead of just 12 though, remember this has to be as a decimal number. So remember back here. So we've got to convert 12% into a decimal. So that's going to be 0.12. And remember, you can always convert a percent into a decimal by dividing by 100, or moving the decimal over 2 places to the left. And so then finally we need our t value, time. And so it says she checks on them 24 hours later, and so that is our t value. So then we've got this nice expression here, and all we need to do is plug it into a calculator. So I'm going to type 100 parentheses 1 plus 0.12 close parentheses, and then to get the exponent you need to use if you're using a TI-30X, you need to use that up button to get into the exponent, and then 24, press equals, and you should get 1,517.862,893, etc. But since we're talking about bacteria, do we really care all those decimal places? Probably not. And so I'm just going to round this to the nearest bacterium. 1,500, I'm going to round up since it's 0.8 to 1,518.